So we're joined all the way from the Kennedy Space Center there in the beautiful state of Florida by Kirk Leucht, software lead at Kennedy Space Center there with NASA. One of the most impressive resumes we have ever had in this class. So we thank you so much for joining us today. I've got a room full here with me at Velma Jackson High School, and we're recording this for all of our friends in Madison County schools, all of our computer science engineering students, our IT Academy, my friend Tiffany Turnage over at MCTC, and my man Willie Bates over there in our Engineering and Robotics Academy. And I have to mention my friend Angela Jordan at Shirley Simmons Middle School. So thank you again so much for taking some time for us today.
You're very welcome. I'm honored to be here. I'm happy to talk about NASA and software and robotics. And I guess we'll start by giving some background on how I got here.
Yeah, because you're from rural Illinois. Went to community college.
Yeah. So don't steal my thunder. Let me give my spiel. I'm kidding. Is it okay if I share my little presentation?
Oh, yeah, go ahead. Yeah, go ahead. We'd love to see it.
Let's see. Hopefully this will work without any issues. All right. Can you see my screen?
Sure can.
All right. So there we go. So as Mr. Pygut mentioned, my name is Kurt, and I'm a software engineer at NASA, and I'm at the Kennedy Space Center in Florida. And I've been working here for 33 years so far.
Wow.
I know, surprising. I have a little bit of a baby face, I guess. But yeah, I've had a nice long career. So let me kind of give you some background and talk about how I got here. I grew up in Central Illinois, which, if you've never been to Central Illinois, it is very, very rural. It's corn country. And so all you see are cornfields and, cattle, pigs. That's where I grew up. And I think I did the other day look up your county, and I compared it to my county, and they're very, very similar in population density. So I imagine your students can relate to the area that I grew up in, where it was very rural. Not everybody who grows up in a very rural area appreciates it in the moment, but I thought that it was a great place to grow up. Everybody is friendly and knows each other and that sort of thing. I do recognize, though, that not every personality is the same, and not everybody might not appreciate it the same. But when I was growing up, this is a picture of 13-year-old me. When I was growing up, I loved computers, and it also turned into I like playing video games just like everybody else. My love for computers turned into a love for software. I wanted to understand what was under the hood, how software worked, how it was designed, how it was coded. So when I was 12, 13 years old, I was writing software programs on my Apple IIe computer that you see there in the picture. And it was harder then because I'm biased. Obviously, my childhood is harder than everybody else's childhood, right? We all think that. But you should know, students, that this was before the internet. Let that sink in. The internet wasn't around when I was 13 years old. It wasn't a thing till I was in college. So there was no YouTube videos for me to watch. There were no websites. There were no people explaining how to do things back then. What I did, the thing that helped me learn the most was some geeky kind of Apple catalogs and magazines that I was able to subscribe to. And this is literally a magazine going up in your mailbox once a month, and you're running out and
Yeah.
getting
Oh
excited
yeah.
about, and in those types of magazines, they always had these little sidebars, and they would say, put this code in your Apple and run it and see what it does. Um, and that's what really where I really started learning. And then some of the more geeky magazines would have like a page full of code, and it would if you typed in that page full of code, you'd have a little game. Um, so every month you got this little cheesy game that you could write yourself. Back then it was amazing. I know to with today's technology it sounds really lame, but back then this was super amazing. Um, and so not only was I into computers and software, I also loved to tinker. I loved to work with my hands. I loved to take things apart and I loved to put them back together. My mom always loved to tell the story about, how little Kurt, I forget what age it was that I took apart her toaster. And this wasn't an old toaster that she had thrown in the garbage. This was her toaster from her kitchen that I took apart. Um, Thankfully, I was able to put it back together and it still worked. But that could have gone another direction. Um, but I loved building things. I loved um, taking things apart and figuring out how they work. Um, and so the erector set was probably one of my favorite toys when I was little. So I had this computer bend, and also had this kind of mechanical um, bend. But I also was very fond of rockets and the space program, um, and airplanes and jets. Um, so all of these things, all of these interests and passions of mine, all made it pretty obvious to those around me that this kid is going to be an engineer when he grows up. I didn't know what an engineer was at the time,
Yep.
um, but I found out later as an adult that um, an engineer just invents things or fixes things, or finds a solution to that. We're just problem solvers. Our boss comes to us with a problem, and we sit down and we rack our brains and we figure out a solution to that. And the solution to your boss's problem could be inventing something brand new that's never been seen before. It could be fixing something that's broken. It could be uh, integrating things that are out there, finding things that weren't necessarily made to work together and making them work together. Um, uh, so I know a lot of students um, kind of shy away from engineering because it sounds scary. It sounds like, oh,
Yep.
only the straight A kid, only that one kid that is the nerdiest of nerds that gets straight A's and has never even gotten an A minus. That's what a lot of students think of when they think of
Yep.
engineering.
Yep.
But I wasn't a straight A student. I mean, I did get good grades, but I got some C's. I mean, I'm going to be completely honest here. Um, and that didn't keep me um, from, becoming an engineer. And grades can be bad grades can be helped. There's tutoring, um, there's, you know, ways that you can work on focus problems. There's ways that you can work on, you know, uh, different personalities learn in different ways. And so I don't want any of the students who are watching this to think that they can't be an engineer just because of their grades. There are tools out there. There are ways to improve your grades, um, and uh, even if you get some bad grades, that doesn't even um, um, cancel out the opportunities for you. Um, Although that being said, it is a highly competitive world. Um, a lot of employers do look at grades first. I try not to look at grades, um, but the sad truth is that a lot of employers will look at grades, and um, because I mean, put yourself in their shoes. If they're getting 100 resumes for one job, they're not they're not going to spend an hour studying through each resume and spend 100 hours just figuring out which ones to interview and which ones not to, because they can't interview 100 applicants. They're only going to, you know, interview maybe 10. So how do they take that stack of 100 resumes and turn it into a stack of 10 and a stack of 90? They have to distinguish between the two somehow, and honestly, the easiest way to do that is just to put a line in the sand and say, if their GPA is above this, they go in this stack, and if it's below this, it goes in this stack. I find that unfair. I like to look at other experience that an applicant might have. I like to look at activities that they do, outside of school, clubs that they are involved in, and that sort of thing. Um, but some people don't do that. So I've gone off on a tangent. I was talking
Yeah, and
about
just to add to that real quick, with
yeah,
our engineering robotics academies that we offer on two of our campuses in Madison County schools, I would encourage any young person that's interested in getting into robotics or engineering or computers to go ahead and get into that now in high school and start getting experience with it. And then you can start getting a few certifications that can transfer into the college range. So there's more opportunities now than there was when we were coming up.
excellent. And let me throw in um, some more good words about robotics, and we can talk more about robotics as I talk about my career more, because we're still looking at 13-year-old Kurt on the slide there, and there's more to the story. But robotics is such an amazing area to to go into, whether it's just as a hobby, um, or a club, or whether it's your final career. Um, there's so many great things about robotics, but one great thing I want to point out, if you're not already aware, um, think about a high school robotics team or a college robotics team. They need people that are smart about computers, uh, that are hooking computers together, and networking. They need people that know about software so that they can write the software on board the robot. They need people that are smart about electronics, that are being going to be able to wire things together. They need people that are smart about um, mechanical linkages and motors, um, and those are the list of technical things. Most robotics uh, competitions and clubs, they need uh, non-technical people too, right? They need planners, they need organizers, they need um, cheerleaders. Not technical, not like they need people to come and fill the stands. They need and they need people to design T-shirts for the team. I mean, artists, creative and art uh, art artistic types of people. So it really takes a diverse team to make that kind of product. So I could talk for an hour on that. So I need to move on. Um, so um, what I uh, what I was saying is engineering is basically just problem solving. Engineers get paid to solve the problems their boss asks them to work on. Um, and so because of that, if you kind of boil down engineering to just problem solving, it's a great field for anyone who's a tinkerer, anyone who's a fixer. Um, it's definitely a great field for technical people, um, but it's also a great field for creative people. And a lot of the world kind of ignores that, and they
Yeah.
focus on, if you're technical, you're going to be an engineer. But um, to solve problems, sometimes you need to have a creative mind too. Um, and sometimes you need to build a team, and some of that team is technical people, and some of that team is creative people. Um, and sometimes one person, has kind of both sides of their brain operating and can kind of fill both roles. And I like to think that I am that type of person who has both the creative side and the technical side. Um, this is just a photo of me showing off to my coworkers some of the engineering challenges that I was able to solve. We had a little expo at work a while back, and that was fun. But let me continue with my career, my path, my background. Um, so before I was an engineer, I told you I grew up in Illinois. I went to school. I went to college in Missouri, but not before going to junior college first. So let me back up. Small town little me, I was kind of shy. Um, when I started looking at colleges and getting tours of colleges and universities, they kind of scared me, especially the big
Yeah.
colleges, University of Illinois, Southern Illinois University. Um, these schools that I was touring had really, really great engineering programs, and I had been told that engineering was probably a good fit for me, and it made sense to me too. Um, but one of the schools that I heard about and hadn't toured was this school shown in this picture, Missouri University of Science and Technology. Back then, it was called University of Missouri at Rolla. And this university was in a small town, and it was a very small school. I have friends whose high schools were larger than my college,
Yeah.
if you can
Yeah.
imagine. I don't know
Yeah.
how big your high schools were. My high school was only 80 some graduating students per year. Very, very small high school, very, very small town. And so I was really drawn to the idea of attending college or university in another small town at a small university. Um, but I want to be very clear. I want to encourage students to go to a college that they feel comfortable with, like I did. Um, every personality is different, so you might be drawn to the big university that has all the stuff and all the uh, you know, it's just crazy, and giant classrooms. And if that's your thing, go for it. You be you. Um, but I also want to um, be clear that you may not get into your favorite college, right? You're going to apply, you should apply to multiple colleges, um, and, just be happy whichever one accepts you. And if more than one college accepts you, then, you know, excellent. That is amazing. Now you get to choose, you get to be in charge. Um, but but for those that maybe didn't get into their very top choice of college, um, I want to encourage you because um, your resume is still gonna have this degree on it, right? Even if it's if I don't want you to think that you're not going to get the job that you want just because of that you didn't go to a specific college. Um, I personally, I'm going to tell you again how I hire. I personally try to ignore as best I can the name of the college that a student went to when I'm hiring. And uh, to be clear, I don't hire full-time NASA people. I do hire a ton of interns. Um, but I'm hopeful that the managers that are hiring full-time employees, you know, have a similar process where, um, you're hiring a person, not a college. Um, a computer science degree from college A and a computer science degree from college B, or whatever the degree is, those students are going through similar experiences and learning, pretty much the same stuff. So I feel like it's unfair to pick one college over another, and I hope other hirers do the same. So don't get discouraged if you don't get into your very, very top choice. Um, it's more important. Um, what you learn in college is more important um, than which college you go to, um, or even how well you do. Like I said, I also try to ignore GPAs
Yeah,
as
and
much as I
also
can.
in Mississippi, our two local community colleges both have 1 and 2 year programs in software engineering, computer science, and network engineering that you can be done in less than a year and already have that certification. And we've had tech professionals say, look, if you've got those certifications and have mastered those programs, we're looking for people that know how to run these programs.
Excellent. And thank you for saying that, because you reminded me that I skipped over my my junior college part of my story. Um, so I skipped right past it. Um, I I was scared. I was looking at these colleges and I was scared because they were big, and I was also scared because um, s- I'm such a small town um, boy that it just seemed maybe I wasn't as mature as some of my other classmates, which is fine. All personalities are different. Everybody's at different levels of maturity, um, and so I decided to not leave home when I graduated from high school, and I went to the local junior college down the road for 2 years, and I think that was a great decision for me, for my personality. It may not be the right decision for everybody. Um, uh, it gave me more time to mature as a human being. Um, it saved my parents a ton of money. Um, they didn't harp on that, but I'm sure in hindsight, they really appreciated the cost savings. Um, and I'm sure that the classes were maybe a little bit easier. I know that the classes were smaller, and so even if the coursework were exactly the same, um, just learning that coursework in a smaller classroom and having more one-on-one interaction with the instructor, the professor, I know was an advantage for me. So there's a lot of advantages to junior colleges and community colleges. So I do want to encourage you to consider that, and um, don't think of it as like um, a lesser choice or anything like that. Um, so to get hired after college, um, everybody who has gone through college and is applying for jobs, they all have a degree, and uh, they all have the same degree if they're applying for a job that requires that degree, right? Um, so anything extra that you can add to your resume that's going to make your resume look better than someone else is going to help you. So, um, excuse me, if you're able to work during college, even if it's part time, excuse me, and add that to your resume, that can really help you um, get hired after college. Um, and your work experience doesn't even have to be in your field of study. Any type of work experience that you can do will show to your future employer that you're a hard worker, um, and that you can work with others. I was very fortunate to get an internship um, or a co-op position while I was in college. I got an internship for NASA here at Kennedy, here in Florida, while I was in college. And most internships work this way. I worked full time for a whole semester. Didn't go to school at all, and then I went back to school, and I went to school full time for a semester. Didn't work at all. So it was just a trade back and forth and back and forth. I did that many times before I graduated, um, and I got my 4-year bachelor's degree in electrical engineering, which may be surprising because I'm like a software guy. Um, but we'll get to that. There wasn't a software degree at my college back then. This is, you know, 30 some years ago, remember? Um, so things were different then. But um, this internship that I had with NASA, basically I was a shoo-in to get hired Do we have a hard cutoff on time? I feel like I might be going
No,
a
you're
little
good.
bit
You're
longer
good.
than we had intended.
No, you're good.
Okay. Um, so don't be afraid to cut me off if I ramble on too
No, you're
long.
good.
Um, so what was I saying? So uh, this internship that I had here at Kennedy with NASA, um, it would have been silly for them not to hire me, right? Because uh, they could see what a hard worker I was. They had many semesters of experience saying what a hard worker I was. That I was not a goof off and that sort of thing. Um, that I was intelligent and I could solve problems, all the stuff. Um, and so they hired me when I graduated. But I do want to stress that sometimes the place that you internship at is not in a position to hire you, and that happens a lot. NASA has two. NASA has a big internship program. Their internship program has expanded hugely since I was in college, and we hire interns constantly. Um, so many that there's no way possible we have the jobs to hire more than just a few of these students when they graduate. But so that's not ideal. But they have this experience now from this internship that they can now put on their resume,
Absolutely.
um, and that goes a long way. So, you know, um, the company that you apply to, um, they're more likely to hire you with this experience on the resume versus a student whose resume looks similar, same GPA as you, same degree as you, and doesn't have this internship experience. Why it seems like they would hire you over the other person, since you have experience in the field, even though it wasn't for their company. Um, so even if I hadn't been able to be hired by NASA, engineering in general is highly sought after by just technical industries and companies.
Or really any industry, even in the healthcare field and in manufacturing, they're always looking for engineers with the technological
True.
advancements. They're always looking for tech people in hospitals. They're looking for tech people in all these factories. So there's more engineering jobs now than ever before. It's more than when you were coming up and I was coming up. Not dating ourselves too much, but the amount of engineering and robotics jobs is multiplied exponentially just in the last 10 years.
Yeah, and continues to grow with no end in sight. So when I first got hired full time by NASA, I was put in a lab, um, the same lab I worked as an intern. This lab's job was to investigate failures of electronic systems. Remember, my degree was electrical
Huh?
engineering, and
Uh-huh.
so we were looking at electronic failures. Um, uh, and we were trying to figure out exactly what caused those failures. We were basically the crime scene investigators of NASA. It was pretty cool. We had all this cool equipment. We had lots of microscopes and lots of complicated testing equipment to test electronics. Um, it was a great job. And my boss, shown in this photo here, this is not a good photo of him, but it's the only one I could find. This was my first boss at NASA. His name is Gary Bassett. He taught me about work-life balance. And as a college intern, um, I didn't know about work-life balance. He made sure I didn't work myself to death. Um, he also he also talked about following my passion, which I was already kind of doing, but he verbalized it and said, "This is important." He said, even he taught me to follow my passion, even if that passion took me away from him and his group that I was working on, because he told me on more than one occasion, if you don't whistle on your way to work, and if you don't whistle on your way home from work, then you might want to look for a job somewhere else.
There you go.
So it was a way of saying you should love the work you do. And if you don't, maybe you're in the wrong place. And I found that that's really great advice. Um, and while I was working in this electronics lab where we were all electronic-y and focusing on circuits and voltages and currents and electronic components, I still had this love for software, you know, in me that wanted to get out. Um, and there was, I found a way to use my passion in this job because we were doing a lot of testing of electronic components using all this test equipment, and it was a lot of manual operations. Um, but we also, in this failure analysis lab, we also on occasion needed to do like long-term stress testing of some component or some circuit board,
Ah,
and that required some automation of the testing equipment, or you'd basically, end up spending all day doing it manually, nonstop. So I got into programming of this test equipment and writing automated software to repeatedly test things over and over.
wow.
Um, and I also um, I also got into some side projects that were software related. Our this was in the early years of the internet, so imagine websites weren't like a thing back then, but they were just starting to become a thing. Our lab wanted a web page or a website, and so I learned about website creation and created the website for the lab, and then I went further than that, and I automated the creation of basically a phone, a directory that had everybody's picture and it had information about them, and I had this basically database that was used to populate these pages on a regular basis. So basically, I um, found a way to use my software passion in this group that wasn't technically a software group. And what happened was my bosses noticed this passion of mine because I really was good at it, and highly productive at this software stuff, and I was good at the hardware stuff too. But it was I was even better at the software stuff. So they noticed how good I was, and this new project came along here at NASA at Kennedy, and that project was to create a whole new software um, system for checking out and launching the rockets out here.
Oh,
And
wow.
um, my boss, I didn't hear about this new software project. My boss, Gary, um, he heard about it because managers, hear about things like that. And he approached me and he said, um, that he knew how much I love software, and if I really wanted to like be a software developer, like a real legit software developer, there was this new project starting up, and if I was interested, and they needed software developers, they needed new people to bring up and train and put them on this project as software developers. And if that's what I really wanted to do for my career, then my boss Gary would introduce me to the managers over in this area, and I decided to do it. It was a little scary, but I was kind of excited and kind of scared, um, and it it I just it worked.
That's awesome.
um, and the rest is history. So I moved into the software development group. Um, I felt really comfortable. I felt more comfortable in working on this pure software project than I felt working in the lab that I had spent 6 or 8 years in prior. Um, we were, as I mentioned, designing a whole new command and control system for use inside the firing rooms here at Kennedy. And if you're not familiar with the term firing room, it's the command and control center. The cameras will usually cut to it during a launch countdown, and all the engineers who are launching the rocket are sitting at their consoles and looking at their data. Um, and that's the project I was put on. Um, it's just a large group of computers, a large group of engineers that sit there and monitor the health and the status of the rockets and the spacecraft, and they control the launch countdown. That was a very cool job, and I worked in that group for about a third of my career. Um,
Wow.
and so skipping forward, the most recent third of my career, I've actually moved into a different software group, one that is doing research and technology for NASA, and we're testing theories that we come up with. We are inventing new technologies in a lab that we call SwampWorks. Excuse me. And the technologies we're focusing on are things that might be needed on the moon someday or on Mars to help us live off the land
Yeah.
and not just not just do what we did during Apollo. As great as Apollo was like just short camping trips on the moon,
Yep.
where they just brought everything, they backpacked everything in that they needed. They lived there for a few days and then took everything back out. Um, NASA's new moon program called the Artemis program is different from Apollo on purpose. It is, well, the first few missions are going to look very similar to Apollo. They're going to be very short term. They'll only be
Uh-huh.
there for a few days. But then as time goes on, the missions are going to get longer and longer and longer. And we're planning missions that are going to spend an entire year living and working on the moon.
Yeah.
Um,
And the first one launches in November, if I'm not mistaken. The first manned mission launches in November, correct?
it's it's not November of this year; it's in November of next year. That actually got
Okay.
moved out
Okay.
recently.
Okay.
um, yeah. So so um, in order to so living off the land on the moon surprises a lot of people. So let me spend a minute on that. Um, a lot of people, let's say most of the general population doesn't looks at the moon, looks at pictures of the moon, and immediately thinks there's nothing there that we could use. It's just a bunch of dust and rocks, right? Um, but scientists have looked deeper and they've thought deeper, um, and they suspected that there was water on the moon, but hiding under the surface, not water ice, because it's like really cold there. Um,
Yeah.
at least when the sun's not beating down on you, it's it's really cold in space, right? Um, and over many years of studying the moon from afar and from above, using our orbital satellites that we've sent there, um, we've gotten data back that says, yeah, it does look like there's ice there, but only in this specific spot. At the poles of the moon, the North Pole and the South Pole, there
Uh-huh.
are craters. Um, and so if you imagine the moon and the sun is out here, at the poles, the sun is at a very low angle. It's like almost at the horizon, you know. Um, and at that low sun angle, there can be a lot. There can be long shadows, especially inside a crater. It can be completely shadowed, and as the sun kind of, I know the sun doesn't move around the moon, but as the sun moves around the horizon, if it doesn't get any much higher, those shadows never leave. And so there's some cold traps on the moon, especially at the poles, especially in the deep craters at the
Yeah,
poles,
because the Apollo missions landed in the middle. They did not go to the poles.
right near the equator, correct. um, and so um, water ice is uh, theorized, and the more data we get, the more
Wow.
these theories are proven to be true. Theorized to have a lot of water ice hiding below the surface, and so the robot in the middle of this picture is an excavator, a digger that we've invented in our lab, um,
Wow.
that is specifically designed to dig in low gravity and also to do it with a small lightweight robot. Both of those were challenges. Those were engineering challenges to dig in low gravity and to dig using a small robot. They did not come naturally. If you imagine, how do we dig how do we dig on Earth? We use really, really big, heavy machinery, right? Um, and that heavy machinery is putting a lot of weight on the ground, and then your digging arm, your digging implement, is basically fighting against the the wheels or the tracks that are on the ground, and they're providing the forces that you need to break the surface and dig below the surface. Well, the reason we don't want to send a 10-ton Caterpillar excavator to the moon is because we don't have rockets that big.
Yeah.
It takes a lot. It takes a large rocket with a lot of thrust in order to send very small things out into outer space. Um, and so the magic um, the magic that we've invented with this low gravity excavator is that it's rotating. Its diggers are on these rotating drums on both ends of the robot, and they're very, very, very small diggers, and so they only take a little bitty bite out every time they come around. So the digging forces are very small, but because they're symmetrical on both the front and the rear of the robot, um, if they if they basically touch or dig into the ground at the same time, some of those the horizontal forces are actually canceling each other out, and you're only left with a little bit of a vertical force. Um,
Oh,
and
wow.
there's some other physics that happens on the moon, because lunar dust particles are very jagged and they kind of stick together like puzzle pieces, that actually makes that horizontal force not a that vertical force not a problem either. The robot, as soon as it starts interacting with this kind of sticky is not the right word, but this these dust particles that kind of fight the digging, it actually sucks the robot down. It actually helps it, um, instead of hurts it. I could talk for an hour on that, but
Yeah.
I don't want to
That's
do
still
that.
pretty cool though. That is pretty cool.
So I don't want to take up more time um, than I'm allotted. Um, I have a few more slides, but there's
Sure.
not really anything super important in them. Oh wait, I do have one more slide I want to show you because it shows
Sure.
you the robot. It's a video of the robot operating.
Sure.
This is just a picture of another project I worked on, which was a swarm of small, inexpensive robots that are designed to search for resources. But this next slide I want to show you because it's a video
Oh,
showing
wow.
our excavator.
So that's the excavator you just showed us in operation
Yeah,
testing. Oh,
yeah,
that's pretty. Oh,
it's
I see
being
what you mean
tested
now. That's pretty cool.
in our lab. We have this big bin full of crushed volcanic rock that simulates the lunar surface. It doesn't simulate lunar gravity, but it simulates the reactive forces that um, the dust particles impart onto our robot's digger. Pretty cool stuff.
That is incredible.
And I'll stop talking with that.
Wow, that is
Because I
incredible. Well,
keep talking
I
to
do have some. I got some students' questions, and I had a few things I wanted
excellent.
to mention quick as well. First of all, I mean, just completely impressive what all you guys are doing there. But a question I had, and I've asked this to a couple other tech people we've had. Obviously, the engineers are a big need in NASA, the IT professionals. But what about tradespeople in NASA? Because something that I've learned is that in these big computer server rooms, they've got to have skilled HVAC people when it comes to building some of these products and things that you guys are testing, you need welders. So, what are some of the trades for maybe some of the kids that say, look, I want to get into this, but college really isn't my thing? Tradespeople are needed
Yes,
even in NASA.
yes, totally valid, even in NASA. So I work at Kennedy Space Center in Florida. You've probably heard of it because we're like
Yeah.
the most popular, the most widely known um, field center at NASA. But if you look at what NASA is really made up of, it's made up of field centers all over the country. I think I lose track, but I think there's like 10 total NASA field centers.
Yeah,
Um,
we have one in Mississippi, the
and
Stennis Space Center, that
yeah, the
does
Stennis, yes, yes.
the launch texting. Yep.
And so each center, focuses on a different thing, but each center um, has a workforce, and that workforce is very diverse. It's not just engineers, not by a long shot. Um, I don't know what the percentages are, but when I first started working at Kennedy, I was shocked that it's like its own city. Not only is it separated, um, location geologically, we have to drive quite a ways to get out here, and it's on a wildlife refuge, so it's really spread out. Um, and so because of its geologic location, um, it takes me a half hour to drive from work, and I'm in the nearest city. I'm in the nearest town. Um, so we have our own police force. We have our own um, fire stations, multiple.
Yeah.
We have, we have our own cafeterias. Um, we have our own um, lawyers. We have our own, office staff. Um, yeah, every group has their office staff, and um, let's see, we have public affairs and media people, groups. We have our education um, and office of STEM groups. It's a very, very diverse workforce, um, and and yeah, a lot of technicians. So the way our projects work, um, the Artemis program that I mentioned, that's building rockets to go to the moon. Um, we have what usually happens is we have NASA people that do initial designing of a new project and maybe throw out you know, uh, some rough details about how things work, and then we create a contract and hire a big um, aerospace contractor to do most of the work, and then the NASA folks just kind of oversee that contract. Um, and these contractors, they hire their own city's worth of personnel, including the engineers, and including the technicians that are turning bolts, and you know that sort of thing. So yeah, I wish I had some numbers in my head, but it's a large amount of not just uh, degreed um, degreed folks, but a large amount of technicians that are just certified in special areas to do special work on these projects.
Absolutely. Now, the last thing I wanted to mention before I get to the students' questions is obviously with this being Asian American Heritage Month, we have several first generation Americans in our school district. And we really want to show that NASA really wants everybody to have a seat at the table when it comes to people of all backgrounds. And I know NASA does a great job of hiring a lot of immigrants and a lot of first generation Americans as parts of their staff.
Yeah, that's true. We have an office um, of diversity. I'm forgetting their full name, but their whole job is to make sure that we are fair in our hiring practices, and make sure that we're hiring a diverse set of the population, and aren't leaving any groups out. And even in our intern hiring, um, there's a certain amount of money that's um, designated as can only be used to hire students from minority serving institutions and things like that.
Yeah, and I know we have a great HBCU here. Jackson State has an electrical engineering program that has partnered with NASA in the last few years. So great opportunities there as well. But I do want to get to a few questions. I'll get to as many of these as I can. This first one is Christian Mitchell. She's a senior graduating in a couple weeks, member of our track team, volleyball team, powerlifting team. But she asked, what are the biggest technical and logistical issues that NASA faces when it has a launch?
What a question. The biggest technical, I mean, this is a little out of my domain, because I don't directly support the rocket launches. Um, but it's important to keep the public safe. Um, and as we spend a lot of time and a lot of energy and a lot of money making these rockets so that they don't explode. I mean, I'm going to be frank.
Oh yeah.
And whether they have astronauts on them or not, we're getting into the Artemis program, which is a crude um, program, um, but we launch a lot of rockets out here that are just launching satellites. I mean, look at
Yeah.
SpaceX's um, recent history, um, and we don't want those to blow up either, right? So um, yeah, there's a whole kind of industry around um, you know uh, putting putting enough safety features on these rockets and these spacecraft to to make them successful. Um, but there's a trade-off there, uh, because this is such a dangerous task that we're doing. You're basically exploding a bomb slowly over time rather than all at once. A rocket is basically a bomb that's exploding slowly over time. Is a very, very simple way to think about it. It's a very, very controlled explosion, and there's always risks. And so there's no amount of money, there's no amount of magic amount of money that if you put this amount of money in it, you're guaranteed not to have an explosion. So everything's a trade-off. So there's always a risk that the rocket will explode, even though we've put all these features on it. There's also a limit to how much mass equipment you can put on a rocket, right? So there's that sort of trade-off. So we have a whole other industry focused around keeping the public safe, assuming that the rocket's going to explode at any point in its mission, and making sure that that event, if it does happen, won't hurt either the workers out here or the general public. And so it's a lot of work and a lot of money goes into it. So it's
Yeah.
probably one of the most critical things we do out
Yeah,
here.
and that goes back to you having to design a machine that was light enough and efficient enough to be carried to space. Because even if it works, if it's too heavy, you've just wasted a lot of time. So there's a lot of
Yeah.
things that go into that, and I think that's part of that as well. I just got time for one more. This is Levon Johnson. He's in ninth grade, very interested in photography, and I know that's a very underrated skill, especially when it comes to NASA. So he asked, as a photographer, what type of skills would NASA be looking for to hire someone?
Yeah, we hire photographers just like we hire our media folks and our education folks. Um, Boy, what kind of skills? Um, this is way out of my domain. Um, I think I think if you're good at photography, regardless of whether you're good at photographing things that move fast, like sports cars, or things that don't move at all, like a still life, or things that are in between, like photographing people or animals. Um, I don't I don't think NASA would say you photograph sports cars, you're in. You photograph, still lifes, you're out. Um, because in the grand scheme of things, these rockets start out moving very slowly,
But yeah,
and it's only when they're way far away that they end up being super super fast. Um, so there are some of our rockets launch in the daytime, some of our rockets launch at night, and you're talking about at night. It's not easy to photograph because you've got a bright flame coming out the end of the rocket, but everything else is dark, and so there's some tricks that the photographers have come up with over the years to figure out how to get the best photos. Um, but but honestly, if you've just got a portfolio of amazing um, photographs to show off, I think that probably puts you at the same level, you know, as as anybody else. I don't think there's a uh, secret recipe
absolutely. I
for
mean,
that.
he's already passionate about it at 14 years old, so that's really cool. So we're
Excellent.
almost out of time. We're almost out of time, and we thank you so much for taking some time for us. That's just so incredible, the work you guys are doing, and it's actually a lot more important than people realize. And that's what I wanted to end on, is that you guys need people.
Mhm.
So why should these kids, no matter who they are, whether they're in middle school, high school, interested in the software side, the hardware side, the engineering side, the robotics side, why should they really learn these skills now to translate into the skills you guys need at NASA?
Well, we're going back to the moon, and old people like myself. I mentioned that I've been working here 33 years, so I don't have that many years left, before I'll be retiring, and so we are always looking to bring in the next generation, um, and to train them, and to pass on information and experiences that we've had before we leave. um, so, and this is probably true for other domains and other career options too. Um, but it's really important. I feel like it's more important for engineering, um, to pass on your knowledge to the next generation before leaving. Um, and lessons learned, we did this and it didn't work out, trying to remember that. Um, and so, yeah, it's important, for the next generation to have to get these skills and to get these jobs. Engineering and the non-degree jobs too are really, um, I don't want to use the word exploding. They're really increasing. I mean, things have really taken off, um, and it's not just NASA. The SpaceX's, the Blue Origins, the all of these other small startup space companies. Um, this whole domain of space and aerospace is just really taking off. So it's a really great area, um, to go into if you have a passion. Don't just do it because you heard that there's good money, or that you heard that it's the area to
I
be in.
agree.
If it's not your passion, you're not gonna like it.
And that'd be the same for any field. But great stuff. And
Yeah.
again, we thank you so much for taking some time for us. It's so cool what you guys are doing there at Kennedy. Kurt Leucht, all the way from Kennedy Space Center there in the beautiful state of Florida. Thank you so much for joining us today.
Thank you very much. I enjoyed it.
I talk to you
Good
soon,
luck,
buddy.
everybody. Bye bye.